Hello students, welcome back to my channel Simplified Chemistry. So my dear students, in a previous session we have discussed a very important theory, that was the payload, and we have already discussed the numerical of it. So now we are going ahead and now we are starting our important law of this chapter, that is known as the Dalton's law of partial pressure. So let us start, my dear student. Now the next theory we are going to discuss today in today's lecture is Dalton's law of partial pressure. Dalton's law of partial pressure. So first of all, before understanding this type of concept, I would like to clear your basic concepts. Clear? I would like to clear your basic concept. So, बच्चों, first of all, you have to understand what do you mean by pressure. What is pressure according to you? So, I am telling you that we are taking one container. In container, suppose we have filled any gas. So you know that this gas atoms or molecules will continuously move here and there, and they will collide with the surface of the container. Okay, so they will collide with the surface of the container, and due to that they will apply some force due to collision. So pressure is what? Force upon unit area is considered as a pressure. Clear? So understood what do you mean by pressure? So you know that gas has maximum property to exert pressure. Okay, how gas will exert pressure? You know that its molecule will do the random motion. Okay, it has kinetic energy, and due to kinetic energy, all the molecules or atoms will collide with the container of the wall, and due to that, pressure will observe. Clear? Okay, so you are familiar with this. Now gases will you show the particular amount of pressure that we have already discussed in a previous lectures. Now suppose you want to measure the pressure of any gas. How can you measure? So for that you required one instrument called barometer. Okay, so by using this particular instrument, you can measure the pressure of any gas. Okay, so I will show you the arrangement of barometer. So how the barometer is look like? So barometer looks like this. Okay, here there will be one particular pipe here. Okay, here markings are given to you. Now this is the arrangement of barometer, my dear student. Okay, here in this barometer, in this tube, they have filled liquid mercury. They have filled liquid mercury, and it has certain markings here. Okay, here it is the 760 mmHg, 760 mmHg, 760 mm, then on and on, markings are there. Now, if any gas is here, so this gas will apply some pressure on this, and due to that, this mercury will go towards upward side. Due to that pressure, mercury will go towards upward side, and so now if it is going here, so according to that marking, its pressure is being calculated. Getting my point? Okay, so if you want to calculate the pressure of N2 gas, so it means you have to take nitrogen gas and you have to fill nitrogen gas into the particular barometer like this. Okay, you have to fill nitrogen in barometer. Here markings are there. Now if you have filled here N2 gas and mercury level went up to this, so this is the particular pressure of that nitrogen gas at constant temperature and constant moles. Clear? For constant temperature, constant mole and constant volume, whatever the amount of nitrogen you have fixed, that will be, it means this marking, suppose it went to 780. So 780 mmHg is the pressure of this nitrogen gas. Okay. Now suppose you have filled here oxygen gas. So whatever the pressure, now for oxygen gas the markings are only 765 mm. Okay. So this will be the pressure of oxygen gas. So this is the individual pressure of nitrogen gas, and this will be the individual pressure of O2 gas. So I showed you that by what is pressure and by which instrument we can calculate pressure. So by barometer, and how it works, that we have already discussed. So Dalton was the great scientist. He observed one important thing, my dear student. So he observed that he took nitrogen gas in barometer and he measured the individual pressure of nitrogen gas, or you can say that here the pressure is applied by the nitrogen gas. Here also he took oxygen gas and he also measured the pressure, individual pressure of oxygen gas. And then here whatever the pressure is that is due to oxygen, and here whatever the pressure is that is due to nitrogen. Now he thought one thing, that if I will mix these two gases, then what will happen? So he named the total, whatever the amount of pressure was there, he named this pressure as pressure of nitrogen gas, and he named this pressure as a pressure of oxygen gas. Now he took a big container, and in a big container, okay, I'm showing like this. Okay, in a big container, he took both the gases, my dear student. Okay, he took both the gases. Oxygen also, he took the same amount of oxygen he took in a big container, and same amount of nitrogen he took in a big container. So now he mixed these two gases. And one important point was that these two gases are non-reactive, inert. Inert means non-reactive. They will not react with each other. So he took that type of gases which are not reactive with each other. React means they will not react with each other and they will not form any type of product. Getting? Okay. So they took these two gases in a same container, and then he found the pressure. Then now he observed the pressure and he found the total pressure. I will name this as a total pressure. So total pressure was equal to the partial pressure of nitrogen plus partial pressure of oxygen. He found that now when we'll mix these two gases together, they are non-reactive. So the whatever the pressure will come, he named this as a total pressure. So he found that total pressure was equal to the partial pressure of nitrogen gas and partial pressure of oxygen gas. It means summation of partial pressure of nitrogen gas and partial pressure of oxygen gas. So have you understood this? Okay, now I will give you the statement. Before that, please take the screenshot and then we will go ahead, my dear student. Okay, so please take the screenshot fast. Okay, done. So now he gave one important statement. So according to the statement of Dalton, it was like that when we mix two or more than two gases, okay, again when we mix two or more than two gases, those are non-reactive, or it is also known as a inert in nature, non-reactive with each other, then total pressure of a mixture, the total pressure of a mixture is the summation of, is the sum of or summation of partial pressure of individual gases. Clear? Getting? Okay, आप समझ रहे हो what is the statement, that when we mix two or more than two gases, those who are non-reactive, inert, so the total pressure exerted by the mixture will be the sum of the partial pressure of individual gases. It means इसको मैं simple ऐसे लिख सकता हूँ. I can easily write here that P total is equal to Pn2 plus O2 in the case of nitrogen and oxygen. Getting this point? So this is very simple law, and its questions are also very easy, my dear student. You do not have to do anything else. Clear? So this was the Dalton's law. Now let's take one example. I am taking three gases A, B, and C. Individual pressure of A gas is zero point 0.5 bar. Individual pressure of B gas is 1.5 bar, and individual pressure of C gas is 2.0 bar. So what will be the total pressure when we will mix these three gas? But one condition is what? They should be non-reactive. They should not react with each other. So these all three are non-reactive gases. When we will mix them, okay, so what will be the total pressure? So can I write here that total pressure will be the partial pressure of A plus partial pressure of B plus partial pressure of C. So partial pressure of A is 0.5, partial pressure of B is 1.5, and partial pressure of C is 2. Clear? So we just have to do the addition. So total pressure will be 4 bar. Okay, why I am naming this as a partial pressure? My dear student, the total pressure is not only because of A, is not only because of B and C, it is because of these three. Because of these three, the total pressure is there. So each and every one is giving their contribution. So not complete contribution they are giving partial contribution. That's why I have to write the partial pressure. So that's why I am writing the partial pressure of A. Clear? Partial pressure of B. In a mixture, whenever we are writing, we will write the partial pressure. Okay, the partial pressure of A plus partial pressure of B plus partial pressure of C. So now you understood that what Dalton said, but there was one condition, that non-reactive gases. So this is also the limitation. I would like to share the limitation of Dalton's law with you also. So the limitation of Dalton's law was only and only one thing, that he gave all this thing for what? Non-reactive gases, inert gases. But those who are reactive, it means if I will keep H2 and Cl2 together, my dear student, in one container, they will form HCl by mixing with each other. Okay, like same thing, CO and Cl2 will also react with each other and they will form the product. So for that type of gases, this law is not correct. This law is not applicable. This law is not correct. So this law is only and only applicable for one thing, that is what? The non-reactive gases. Like non-reactive gases are what? Like N2 and O2, that we have taken the example, N2O2, N2Cl2. Okay, so you have to remember this. Clear? So this is the Dalton's law, and this is its mathematical derivation. Okay, and this is its limitation. It is only and only applicable for the non-reactive gases. It is not applicable for the reactive gases. Clear? Okay, so we have to prove certain phenomena, and that we are going to discuss now. Clear? Before that, please take the screenshot. Okay, good. So as you know now this is very simple mathematical steps. The small children of even the 9th 10th standard can also do this. So we just discussed that P total is equal to what? That PA plus PB plus PC. It means total pressure of the mixture of non-reactive gases. See, I am mentioning you non-reactive gases so many times, so it should go in your mind directly. Okay, partial pressure of A plus partial pressure of B plus partial pressure of C. Clear? Now, my dear student, we all are familiar that PV is equal to nRT. This is our ideal gas equation. But if we want to take, see, in this condition, whenever we have taken them into the container, at that time, volume, temperature, R and P, what was the condition of this? Okay, what was the condition of this? So volume was remaining constant. In particular container, volume was remaining fixed, constant. Temperature was also constant, and gas constant is itself a constant. So pressure was changing, and moles are variables. It means moles are different in all these three. In PA different moles will be there, in PB different moles will be there, and PC different moles will be there. So here two variables are there, only pressure and moles. So can I write here that PA V is equal to NART. All rest of the things will remain same. I can also write this that PBV is equal to NBRT. I can also write this PCV is equal to NCRT because only two variables are there, pressure are different and moles are different. That is only thing. All rest of the things are remaining same, constant. Clear? So now I am substituting the value of PA. So can I write this that NART upon V? Here also I can write NBRT upon V. Here also I can write NCRT upon V. So now I can easily write, my dear student, that P total is equal to PA plus PB plus PC. So can I write here like this, NART upon V plus NBRT upon V plus NCRT upon V. Clear? Okay, so RT by V will be common, my dear students. Clear? These are the simple mathematical forms. So here you can simply write that P total is equal to NA plus NB plus NC into RT by V, where R is equal to gas constant, T is equal to temperature, and V is equal to volume. So can I write here that P total is our this formulas? So this will be the very useful formula for the numericals. Okay, that P total is equal to Na plus Nb plus Nc into RT by V. Now if anyone will ask me, sir, only two gases are taken, then only we will write Na plus Nb, nothing else. Okay, at that time we have to write what? Na plus Nb, nothing else, my dear student. Clear? So this is the formula. Now for only a gas, what I can write? So I can write NART upon V. Clear? Simple thing, NART upon V. So this is our formula also for, and this is also what you can say that partial pressure of gas A. So partial pressure of gas A is equal to what? NART upon V. Now, if I am taking the ratio, if I am taking the ratio of equation number 1 and equation number 2, so I can say write here PA upon P total. Can I write here PA upon P total? So PA is equal to what? NART upon V, and P total is equal to what? Na plus Nb plus Nc into RT upon V. Now the magic will happen. See, RT upon V, RT upon V are remaining same. So it will be cancel out. So it will be cancel out. So now remaining part will be what? PA upon P total is equal to Na upon Na plus Nb plus Nc. Have you strike something? It means something has striked in your mind or not. If you have done the mole concept with me and concentration with me, you will be that genius to understand this. Can you remember something on the basis of this, my dear student? These are what? Moles of A upon moles of A plus moles of B plus moles of C. So can I write this that PA upon P total is equal to this what? Moles of A upon total moles. याद आया कुछ मेरे बच्चों? Moles of A upon total moles means what? Mole fraction. Mole fraction, yes or no? We have already studied the mole fraction. The mole fraction is equal to XA is equal to what? Na upon Na plus Nb. Moles of component upon total mole. Xb is equal to what? Moles of B upon moles of A plus moles of B. So similar thing happened here. Moles of A upon total moles. So can I write here that Pa upon P total is equal to XA, because XA is equal to what? Moles of component upon total mole. Yes or no? This is very simple. So can I write my formula that partial pressure of A, now P total I am sending on this side, is equal to P total into mole fraction of A. So this is also important formula for the numerical, that PA is equal to P total into XA. Also I can write for PB also. So PB is equal to what? P total into XB. So understood this? Clear? Also I can write PC is equal to P total into XC. So in short, we understood that partial pressure of any gas is equal to total pressure into its mole fraction. So these three formulas are very important for our numericals. Still, we have to discuss much more formulas. Before that, please take the screenshot. Okay, clear? Okay, very nice. Very nice. You are doing really great. Now, I would like to uh, ask you one question, one important question I want to ask you. That we have taken one container, in that I have mixed A plus B plus C, three gases. And suppose I want to find out the percentage of a gas. It means suppose I want to find out the percentage of particular A gas in this mixture. So I can simply write this, that pressure of a gas upon total pressure into 100. So I will get the percentage. This is simple one. So if you want to find out, my dear student, percentage of a gas, so what you have to remember, the percentage of a gas is equal to what? You can simply say that partial pressure of a gas upon total pressure into 100. So suppose you have to find out percentage of B gas. So what you will do? So partial pressure, you will write here what? That partial pressure of B gas upon total pressure, P total, into 100. So you will get the percentage. So this is also one formula that you have to remember, okay, for the numericals. Okay, my dear students, now please also take the screenshot. Now the thing I want to explain you is very, very interesting and very, very understandable. Clear? So let us discuss that. Sometimes you will find this word that we are collecting gas over water, collecting gas over water. So what is the statement? So it means you can easily understand this English, sir. They want to tell that we are collecting water on the sorry, we are collecting gas on the water surface. So now you know that it is very difficult. It is very, very difficult to fix a gas in any container. It means suppose I am giving you any container. In this container, suppose you have to fill the gas. It is very, very difficult, my dear student. You know the DEO or any spray. So if you will spread this, it will spread throughout the room. Clear? So it is very difficult to fix them. It means put them into a particular box. So for that, we are using one technique. So this is particular technique, and I am going to show you that technique. And we are going to take first of all one beaker, and in that beaker we have to put one particular inverted column. We have to put what? Particularly inverted column. All the water is filled inside the beaker. Water is filled inside the beaker, so you do not have to worry about anything. So water is filled. Now my dear student, I want to tell you one important thing, that few students are having so much misconception. So clear your misconceptions here. I want to tell you one thing is that if we are talking about 0 degree Celsius, it means 273.15 Kelvin. At this temperature also, water will have some vapor. Water will have some vapor, my dear student. Still I am telling, okay, at any temperature water will have some vapor on it. Clear? You know that at 25 degrees Celsius, of course there will be some vapor over the surface of water, but my dear student, this you have to remember, at 0 degrees Celsius also particular amount of vapor will be there on the surface of water. At 0 degrees Celsius, less amount of vapor will be there. At 25 degrees Celsius, more amount of vapor will be there. And at 100 degrees Celsius, maximum amount of vapor will be there. Clear? We are familiar with this. It means I have filled water in this, and now I will connect barometer with this particular instrument. Barometer I will connect. So by applying the barometer with this container, I will be able to know the pressure exerted by water vapor on this water, yes or no. It means I am telling you, I am showing you with a different pen that here there will be some water vapor situated here. So they will be applied some pressure on this, the wall of this inverted column. Clear? Okay, they would be applying certain pressure on this wall of the inverted column. So that pressure you can find out by putting barometer in connect with this container. So we found that that particular pressure is known as a aqueous tension. It is known as what? Aqueous tension. It means you can simply say that the pressure of vapor of water, the vapor pressure of a water is considered as what? Its aqueous tension. Only water vapors are there, and the pressure exerted by water vapor on the surface of water, it is considered as an aqueous tension. It is considered as, my dear student, aqueous tension. Understand this concept really nice. Okay, now suppose you want to fill certain gas in this column. So at that time, what you have to do? You have to arrange certain assembly like this. You have to arrange certain assembly like this. And here I have to pass nitrogen gas. If I will pass nitrogen gas from here, so it will come here in the form of bubbles. It will come here in the form of bubbles, and then bubbles will convert into the vapor. It is found that nitrogen is almost insoluble in water. It means only 23 ml of nitrogen can dissolve into the 1000 ml of water. On the base of this, you can imagine the very less amount of nitrogen will dissolve into this water. Other nitrogen particles will come here, and also they will mix with this particular aqueous tension. It means you can say that TH2O. Okay, vapor pressure. ओके, अंडरस्टूड, क्लियर। फिर से बता रहा हूं, हिंदी में समझा रहा हूं, अगर किसी को इंग्लिश में नहीं समझ में आया तो मैंने पहले क्या किया अभी समझ लेना। ठीक है, बहुत ही सिंपल सी बात है। नाउ अंडरस्टैंड इट प्रॉपरली। मैंने क्या किया, पहले खाली पानी लिया। मैंने कहा क्या कि कोई भी टेम्परेचर एट एनी टेम्परेचर पे वाटर वेपर में कन्वर्ट होता है बट 0 डिग्री सेल्सियस से बहुत कम प्रपोर्शन में। इट मीन्स वो जो था, हमने उसका प्रेशर अगर मेजर कर रहे खाली 25 डिग्री सेल्सियस पे भी खाली मैंने वाटर का वेपर का प्रेशर फाइंड कर रहा हूं तो उसे एक्वियस टेंशन कहा जाता है। ओके, जिसे वेपर प्रेशर ऑफ वाटर कहा जाता है। ठीक है, 100 डिग्री सेल्सियस पे खाली अकेला पानी हो तो। अभी हमने क्या किया, इसमें हमने नाइट्रोजन ऐड कर दिया। नाइट्रोजन ऐसे ही ऐड, क्योंकि नाइट्रोजन पानी में सॉल्यूबल नहीं होता है, बहुत ही कम सॉल्युबिलिटी होती है। 23 ml जितना ही नाइट्रोजन डिजोल्व होता है 1 लीटर पानी के अंदर। तो अभी क्या होगा, नाइट्रोजन के बबल्स बनेंगे, तो बबल पानी में तो डिजोल्व होंगे नहीं, तो धीरे धीरे ऊपर जाके ये वाटर वेपर के साथ में रहेंगे। मिक्स नहीं होंगे, रहेंगे। मिक्स नहीं होंगे, रहेंगे। अभी मैं बैरोमीटर लगाऊंगा दोस्तों। अगर अभी मैं बैरोमीटर लगा रहा हूं तो मुझे टोटल प्रेशर मिलेगा। किसका टोटल प्रेशर मिलेगा, अभी देखिएगा। अगर अभी मैं बैरोमीटर लगा रहा हूं तो आई विल गेट द टोटल प्रेशर। द टोटल प्रेशर ऑफ व्हाट? PH2O प्लस PN2, जिसे N2 ड्राई गैस कहते हैं। ठीक है, इसे ड्राई गैस कहा जाता है N2। तो ये दोनों का मिक्सचर मिलेगा अगर मैं बैरोमीटर अभी कनेक्ट कर रहा हूं तो। PH2O का भी मिलेगा, PN2 का भी मिलेगा। तो अगर मुझे PN2 का फाइंड करना है तो पहले मैंने जो PH2O का फाइंड किया था, तो P टोटल में से उतना मैं PH2O कर दूंगा तो मुझे PN2 मिलेगा। इट मींस कोई भी ड्राई गैस का प्रेशर फाइंड करना हो जिसको वाटर की सरफेस के ऊपर कलेक्ट किया गया हो, उसके लिए हम फॉर्मूला लगाएंगे, प्रेशर ऑफ ड्राई गैस इज इक्वल टू टोटल प्रेशर माइनस वेपर प्रेशर और एक्वियस टेंशन और द प्रेशर ऑफ अ वेपर। getting it? This is a really easy concept. Clear? But I explain you in a very easiest way and understandable way. So hope you have cleared your all point. My point was to tell you this only, that suppose you are collecting any gas over the water. At that time the particular gas pressure will be P total minus P H2O, because in numerical sometimes we have to apply this formula also. Clear? Please take the screenshot. I will sum up all the formulas in front of you that we have to use in the numericals, and then we will go for the numericals. So please take the screenshot of this fast. Okay, so now let me write all the formulas together, so that we have derived on the base of Dalton's law. And on the base of this, we have to solve the numericals. The first formula we derived is P total is equal to partial pressure of A plus partial pressure of B. But always remember, these gases should be non-reactive. Clear, my dear students? So this is the first equation. Then partial pressure of A is equal to what? Na RT upon V. On the place of Na Wa RT upon V, you can also use. Okay. Then also we have already found this. P total is equal to what? Na plus Nb into RT by V. Na plus Nb into RT by V. You can also write this formula in this manner, that Wa upon Ma plus Wb upon Mb into RT by V, because moles is equal to what? Mass upon molecular mass. So you can also write this formula in this manner. Then we have discussed that partial pressure of any gas is equal to P total into mole fraction of that gas. Clear? Again, I am writing the formula of mole fraction is equal to what? Moles of component upon total mole, Na plus Nb. Now percentage of a gas is equal to what? The partial pressure of a gas, partial pressure of a gas upon total pressure. This is very simple. Clear? Upon total pressure into 100, and pressure of any dry gas is equal to total pressure minus pressure of water. This rule is only applicable when gas is collected over the surface of water at that time. So these are all formulas. On the base of this, we have to solve numericals, and we will keep numericals in the next lecture. Okay students, so it was up to this only. Hope you have liked my video, and if you have liked the video, please press the like button, share to the students, those who cannot afford the tuitions and all. Clear? And subscribe to my channel. Thank you so much, my dear students, for your love and concern. In next lecture, we are going to discuss about the numericals of Dalton's law. But before that, these things are very important to you. So please go through all the formulas, how we have derived it. Clear? And you have to remember this. Also, whenever we are solving the numericals, terminology matters. So terminology is N means mole, R gas constant. That you should know. Pa partial pressure, we are talking about P total, everything. Clear? So if you know this basic concept, you will be able to solve any of the question, and these are all formulas based on Dalton's law. Okay, thank you so much, my dear students. Bye bye, take care.